Okay, let's talk about a circle and the equation for a circle and the graph of the circle. Now, the circle, as you can see here, has an equation. X squared plus y squared is equal to r squared. So some defining features are, well, x squared's not such a defining feature, but certainly x squared along with y squared, when you see the two of them together, then that is the key, that this, it's not a function, but that this equation will graph to give you a circle. So an x squared plus a y squared is then equal to an r squared, and r then is the radius. So certainly when you see perfect squares, and it doesn't have to be a perfect square, but if you do see a perfect square, so for example, if you saw x squared, let's get the pen going, x squared plus y squared is equal to 9, you would know you have a circle, center the origin. These circles have their center at the origin. And this one would be center at the origin and radius 3, because this number here is r squared. So out here 3, up here 3, and just a little piece of advice, make your scales the same on both axes when you're drawing circles. Don't do this sort of thing. We'll make 3 up there, but I've run out of space here, so I'll put a 3 and a -3, and right down here will be -3, because when you draw that, it doesn't look much like a circle. The only reason it doesn't look like a circle is because we've got different scales on each axis. So instead, try to put the same scale on each axis. So looking at this circle, center is the origin and the radius is 1. So this circle is going to have the equation x squared plus y squared is equal to 1. Now, like I said before, these the radius doesn't have to be a perfect square. So when we've got that, if we have x squared plus y squared is equal to 2, for example, and 2 you can see is not a perfect square, then we still have a circle because we've got the x squared and y squared. It still has its center, the origin. So however, now r squared is equal to 2. So r, the radius, take the square root of 2. And of course we don't take the negative square root in this case because a radius can't be a negative value. Come to sketch that, we are just going to assign root 2, as that we have no other values on our axis, we're just going to assign root 2, for example, to be that distance. We're saying that's root 2. Remember, we're keeping the scales the same on both axes, so that's root 2. Over here we've got minus root 2, and down here minus root 2. And so we draw our circle with center the origin, radius, root 2. And that then applies to any other number here that's not a square, that's not a perfect square. I guess if there are some values actually stated on the axis, so if you were given a number plane and this was 1 and this was 2, and you were drawing this exact same circle with a radius root 2, then you would be estimating where the square root of 2 is. And if you're unsure about where the square root of 2 is, then you take your calculator, do square root 2 equals, it's approximately 1.5. So we would be estimating about halfway between here. And again, we don't call it 1.4, or as we saw on the calculator, or approximately 1.5. We keep it square root 2. We really only went to the calculator to get an idea of exactly where that was in terms of 1 and 2, the whole numbers. And like I said, you really only have to do that anyway if numbers are already given on the axes on a number plane. But like you could see here, if you get to choose and draw the number plane yourself, then it's a good idea not to put any of the whole numbers on and just assign the radius value on each axis. Now, a common, and it becomes a function, a common function is a semicircle, just half of this. So let's see where this actually comes from. We know that with a full circle, we've got the equation x squared plus y squared is, now I'm just going to go to the a squared rather than the r squared, just because it's the notation used here. And there was no reason why I couldn't have been saying up here for a circle that a circle is in the format x squared plus y squared equals a squared. I'd only used r because we have an understanding of r as the radius. If I now make y the subject, well, first step would be to make y squared, then we get this a squared minus x squared. So if I wanted all of that, and by the way, if you see something in this format, then again you know it's a circle. That is a circle. Even though the x squared is written over on the right hand side, you can certainly rearrange it and put the x squared and the y squared together so that it satisfies what your understanding of the equation for a circle actually is. But we're working towards getting the equation for a semicircle. So if I just wanted the positive y values, just the positive y values, then I write that in this format here, that y now is the square root of a squared minus x squared. And so I would have the positive values of the y values of the circle only, and the positive y values of the circle obviously sit up here. And again, the reason that here in this example it doesn't look so much like a circle, certainly doesn't, is because you can see the difference in the scale. And this is what I'm saying, keep your scales the same. So if that distance there is 1, and then we make this distance be 1 on the other axis, this is why this is not really looking like a circle. The negative, you can also see, again, I copied this from a drawing program online, and they had already set the axes on the scales on each axis, so it looks out of proportion. But this would then be the equation of the bottom half. The y values must be all negative, the square root of a squared minus x squared. Please familiarise yourself with that equation, because that does often come up, and you're expected to recognise that one obviously as a semicircle. Just be aware that you've seen a square root before, but it was actually y is equal to the square root just of x. Now, hopefully you remembered that as half a parabola on its side. Now, we know that a parabola up the right way is y is equal to x squared. And that's going to be a parabola looking like that. We'll do more work on this in another chapter. When you have y squared equals x, reversing these roles, so y goes to here, x and y just swap, then this is a parabola on its side. X equals y squared is this parabola. Then, going back again, when we write this as y by taking the square root and taking the square root of that side, then we do get two potential answers, the positive square root, for example, and the negative square root. So the positive square root would graph to be the top half of the parabola on its side, and the negative square root would be the bottom half of the parabola on its side. So don't confuse these with parabolas, because these actually have the x squared underneath the square root, and this one just has x under the square root. I'll pause the video there and then make another video on circles where the centre is not the origin.